Welcome to Spring LIB.
We are given these two half reactions as well as the overall reaction for an experimental fuel cell, and we want to determine what the cell potential is at certain conditions for a value of delta G to be negative 380 kilojoules. At these conditions of about 800 degrees Celsius, we are told that the value for the change in Gibbs free energy is negative 380 kilojoules. So we know the equation that relates delta G and cell potential is delta G at non-standard conditions, in this case, is equal to negative NF E at non-standard conditions, and we are trying to solve for E. So we can rearrange that equation to say that the cell potential at these conditions is equal to delta G divided by negative NF. And so now we can plug in what we are given in the problem. We were told that delta G is equal to negative 380 kilojoules. And we should convert this into joules by multiplying by 1,000 so that we have joules per coulomb, which corresponds to volts in the end. We divide this by negative N, and we can see from the two half reactions that we have to multiply the top one by 2 to cancel out a total of 4 moles of electrons on either side. So N is equal to 4 moles of electrons. And F is Faraday's constant, 96,485 coulombs per mole of electrons. And now when we plug that all in to this expression for the cell potential, we should get a final answer of about 0.98 volts.